Well, welcome. All right. It's been a while since we've had to listen to some notes or got to listen to some notes, and tonight we're going to start this up again. Tonight's notes are going to be about probability, so quite a bit of this is going to be review, but not all of it. Probability is the calculated likelihood that a given event will occur. There's a probability when it comes to all types of gambling, games that we play, and the weather is a big time probability. Methods of determining probability. There's empirical and theoretical. Empirical is when we have experimental observation. Um, you've done an experiment and you come up with a probability. For example, you flip a coin, let's say 10 times, and during that, didn't mean to flip pages there. Let's say during this time you flip that coin and 7 out of 10 times you get heads. So your empirical probability is 70%, or 7 out of 10 times you're going to get ahead when you flip the coin. But theoretical, we know that obviously one side's a heads, one side's a tails, so you'd get theoretically it should be 1 out of every 2 times, or 50%. So there are two different types of probability. There's empirical and theoretical. Empirical is based off of experimental observation. Theoretical is using the known elements, but empirical again is off of experiment, basing it off the experiment. Subjective assumption. This is an assumption, I think, so we won't really work very much at all with assumption. Probability components is, first of all, we talk about the experiment. This is the activity that you're going to be observing. Sample space is a set of all possible outcomes. How many different outcomes can we get here? If I flip a coin, there's 2 outcomes. If I roll a dice, there's 6 outcomes. Event is a subset of sample space. We'll get into that more later. And then outcome is what happened when we did the experiment. All right. Again, this is the result. This is what happens when we do the experiment. All right. Here's an example now of all these keywords here that we talked about. We have the experiment is the actually flipping of the coin. The sample space. Well, when we start to write out our probability tree, and you've all have done this in math classes, you can either get a heads or a tails when you flip it. Event. Well, what actually happened when we did it? Well, we got a heads. All right, and the outcome then was the heads. So this kind of, again, the experiment. What are we doing? We're flipping a coin. Sample space tells us what are our possibilities, heads or tails. The event, what did we get? We got a heads. And then the outcome, obviously, was heads. Okay, some things I want you to know about probability. We're going to typically express that as a number between 0 and 1. It's going to be a lot of times written as a fraction. Um, we're going to use numbers like 1/2. Or we're going to typically, the other thing you'll get is as a percent. All right, as a percent. The other options aren't quite often used. The other thing I want you to know is the total probability. The total probability is going to have a total of 1. So, meaning something has to happen every time you do this experiment. Okay, relative frequency. The number of times an event will occur divided by the number of opportunities. So, the relative frequency of an outcome. So what we're kind of getting in here to then is theoretical, all right, not theoretical, I'm sorry, experimental probability. All right. Relative frequency of outcome X, so that's going to be out here. How often is it going to happen? N over X, or NX, N of X, the number of events with outcome X, and the total number of events. And the reason I say that we're talking about experimental probability here is because we're talking about events and outcomes. Again, it's going to be expressed as a number between 0 and 1, and a lot of times we're going to either give it as a fraction or as a percent. Okay, what is the probability of a toss coin landing heads up? We know it's 1 out of 2. All right. How many desirable outcomes are there? There's 1. It's when it's heads. How many possible outcomes? Well, there could be 2 of them, heads or tails. So the probability becomes 1 over 2. What is the probability of a coin landing tails up? Again, desired outcomes, there's 1. It's a tails. how many total outcomes are there? There's two of them, heads or tails. So it's still 1/2 or 50%. What's the probability of tossing a coin twice and it landing heads up both times? Well, here's an example where we have desired outcomes. How many possible outcomes? Well, we've made a tree. Each time, each one of these is an event. Here's an event. This row represents an event. This represents the outcomes. So we have a heads and a tails. First event, you could flip a heads or a tails. If you flipped a head, the second time you flip, you could flip a heads or a tails again. There's only those two choices. Well, what are the outcomes? You could have a heads and a heads, so they have heads, heads. You could have a heads and a tails, heads, tails. But what if you'd flipped to tails the first time? The second time you flipped, it still would have two choices, heads and tails. And your outcomes would be tails and heads, tails and tails. So these right here are events. And that's an outcome, a list of your outcomes. Okay, the binomial process. Each trial has only two possible outcomes, yes or no, on or off, right or wrong. Trial outcomes are independent. Tossing a coin does not affect future tosses. And what that means is, on the first toss, if I toss it and get a heads, that doesn't have anything to do with what's going to happen on the second toss. The second toss, I still have an equal number of chances. All right, let's talk about the Bernoulli process here. This is a way of finding a probability. Okay, in this, probability is what the P stands for. X, the number of trials for a specific outcome within n trials. So X stands for how many trials are we going to do. I'm sorry, X stands for the number of times specific outcome within n trials. So this again is still just probability. Don't get caught up in that. N equals the number of trials. So how many times are we going to do this? Q is the probability of success on a single trial. P is the probability of success on a single trial. Q is the probability of failure on a single trial. And then factorial. Factorial minus the product of all integers less than or equal. Okay, let's take a look at this example here. I'm going to kind of flip back and forth here. Again, P is the probability we're trying to find. And now let's find out where this information came from here. What is the probability of tossing a coin 3 times? Well, remember, P of X, the little p stands for probability of success on a single trial. Sorry, I got ahead of myself. Let's look at n. N is the number of trials. We're going to do it 3, and it's factorial, so it's going to be, we're going to toss it 3 times, so it's going to be 3 times 2 times 1. P is the probability of it happening correct. And then X is the number of times that we want it to land, how many times we want it to land heads up. So its probability here, each individual time has a probability of 0.5. This is theoretical. And we want it to land heads up twice, so it's 0.5 squared. All right. Q is the probability of it not working. Well, if it's 0.5 of the time it's going to work, then 0.5 of the time it's not going to work. And that would be 1 time. If it's going to happen 2 times correct, then the third time would have to be not correct. Some things I want you to understand here about this. These two right here are going to add up to 3. Why? Because we're going to toss it 3 times. If this number here was 4, then they would have to add up to 4 right here. So however many times you're going to toss it is what these two numbers right here are going to have to add up to. The exponents have to add up to. On the bottom, X, right? X is how many times we want it to happen correctly. So it's 2 times 1. And then again, the number of times it's not going to happen, that'd be 1. So it's factorial, 1 times 1. When we do this all together, we get 0.375 or 37.5%.